In this lesson, we're going to take our first steps into solving derivatives using one of the most powerful and easy to use tools in calculus, the power rule. We'll start by learning how to apply it symbolically, working through a few examples together so that we can see the pattern and how it works. Then we'll move to numeric practice, checking our answers using an online derivative calculator and a TI-84 graphing calculator. The goal is to understand how to use the power rule, but also to gain confidence that your answers are correct by verifying them with technology. By the end of this video, you should have a clear process you can follow each time you face a derivative problem. The power rule says that d sub dx, or d in terms of dx, for ax raised to the power of b, where a is a constant and x is raised to the power of b. So what we want to do here is we want to take this power and bring it in front. So we'll have b times a times x, and this b here, we're going to say this is b minus 1 now. That's basically what the power rule is. We're going to be working problems symbolically as well as numerically. Now, to check your answers, I would suggest using this website here, okay, derivative-calculator.net. Do not go to the .com, because that website is not nearly as good as the one which is .net. If you have an upper end calculator, like a TI-89, anything in the 92 family, the TI Inspires also work really well. As long as it has the compute algebra system or CAS system, any basic TI-84 and higher calculator will be fine for getting numeric answers. Let's start with a fairly simple problem here. So let's start with a simple example. dx for 2x to the negative third power. The first thing I want to do is I want to take this negative 3 and bring it in front. So I would have minus 3 times 2x, so that would be minus 3 minus 1. So that will give me minus 3 times 2x minus 4. So now let's multiply it out. 2 times 3 is 6. So that's 6x to the negative 4th power. That's my answer. But we can put it in a better format by saying this negative 6 over x to the 4th. So this would be my symbolic answer. Now, what if the problem says, solve this for x equals, let's say, 5, okay? So what we would do is take this answer, minus 6 divided by x to the 4th power, and we're going to put a 5 here for the x. That'll be minus 6 over 5 to the 4th power. My answer is negative 0.0096. This is my numeric answer. And this is my symbolic one over here. Now, how will we check this answer to make sure it's correct? Let's go to the website. Okay, here we are at the website. It's in our equation, so our d over dx is equal to, so we're going to say 2x raised to the negative 3rd power. So it's something that looks like that. Hit go. So first I simplified my input, and it gave us the same answer we had earlier. So that's negative 6 over x to the fourth. Okay, it gave us some nice graphs. So that the blue line is the function, the red line is the derivative. If I said, let's let x equal 5 like we did earlier, the derivative of prime of x is 0.00960. It's the same answer we got earlier. To check this on a graphing calculator, go to y equals and enter our original equation, which was 2x raised to the negative third power. Okay. Okay, if you would like to see this graph, let's go to zoom and 9. And there's our graph. Okay, so to get the derivative, we go second trace, which is calc. And we're going to go down to dy dx, which is number 6. Now I want to enter the value for x. If I put 5 here and press enter, it's going to give me that dy dx is equal to negative 0.0096. The same as we got earlier. Okay. There's another way. If I go second and hit catalog down here, and if I hit the letter N so I can speed on down to the ends, I want to go to NDRIV. So cursor down to there and press enter. So D over D, I want an X there. I want 2x raised to the negative 3. And then I want my x to equal 5. I press enter. So we get the same answer again. I like this one the best, but you can choose which one you like. Okay, so we got the same answer as before. Let's try this polynomial this time. All right, so I need to do each part separately. Essentially, this is the same thing as saying d over dx for 3x to the 8th plus d dx of minus 6x to the 5th plus d dx 9x squared plus d dx for negative 4. Okay, so solve each one of these. I'm going to skip a couple steps. So I'm going to take my 8 over, so the 8 goes in front. So I have 8 times 3x to the 7th power. Bring my 5 over. 5 times negative 6 is negative 30. X to the subtract 1, 4th power. Bring the 2 in front of the 9. 2 to the 9 is 18. X to the 1st power plus 0. All right, so 3 to me is 24, x to the 7th minus 30, x to the 4th plus 18x. This is my symbolic derivative. So if I say if x equals 2, substitute a 2 for all the x's. So that'd be 24 times 2 to the 7th power minus 30 times 2 to the 4th power plus 18 times 2. So this would be 24 times 128 minus 30 times 16 plus 36. Okay, solving this in my calculator, I get 2628. Okay, let's check our answer. Alright, so I have 3x to the 8th minus 6x raised to the 5th power plus 9x squared minus 4. Okay, that looks right. So it says that the symbolic answer is 24x to the 7th minus 30x to the 4th plus 18. Hey, that's what we got earlier. Okay, we said let x equal 2. So if I say x is 2 here, then we get for the derivative 2628. So again, our answer is correct. All right, let's check it on the calculator. Okay, let's try this on the calculator. From y equals, I will say 3x raised to the 8th power minus 6x raised to the 5th power plus 9x squared minus 4. I'm trying to verify, make sure it's correct. So let's go to second trace. Go dy dx. Okay, if you want to see the graph better, hit zoom in 9. All right, zoom 9. And then we'll tell it to calculate for x equals 2, not 5. Dy dx 2628. And let's go ahead and do the second catalog. We'll go to n. We'll do n derivative. So it's going to be d over dx. The x is going to be 3x raised to the 8th power minus 6x raised to the 5th power plus 9x squared minus 4. And for value of x, we're going to go with a 2. Again, we have the answer, so it verifies. Okay, let's try one like this. First thing you want to do is get everything up in the numerator. So I'm going to let this be 4 times 1 over x squared. Let's get the x squared to the numerator now, so that'll be 4 times x to the negative 2nd power. And that fits better for doing the power rule. So let's bring the 2 in front. So that'll be 2 times 4 times x minus 2 minus 1. That gives us, that's a minus, so that'll be minus 8 x to the negative 3rd power. So that'll be minus 8 over x to the 3rd power. Okay, what if we said that x is equal to 1.5? So we will say minus 8 over 1.5 to the 3rd power. That gives us negative 2.370 and change. Okay. So we have 4 divided by x squared. So we get negative 8 over x to the third. Good. And if we put 1.5 here, we get the same answer as before. Okay, so on this one, I'll give you something like your math teacher would give you. In this example, I'm going to give you one that's a little bit more difficult to enter into the computer program. I have 5 the 5th root of x squared. It's going to be difficult to enter the 5th root. Okay, so let's go ahead and use a little algebra skills here. This is the same thing as saying 5 times x raised to the 2/5 power. So the square goes on top and then the root goes on the bottom. So now we can say then that so I'm going to bring my 2/5 in front. That'll be 2/5 times 5x to the 2/5 minus 5/5, because it has to subtract 1 from this. So this would be 2/5 times 5x to the negative 3/5. 5's cancel. So I have 2x to the negative 3/5. So that's equal to 2 over x to the 3/5. So that will be the derivative for it. Let's enter this into the computer. I have 5. I'll press square root. I'm going to go to the nth root. And I want to cursor back where it says n. I'm going to put the 5th root, comma. And then I have x raised to the 2nd power inside the root. So that's how you would key that in. And we get 2 over x to the 3/5 powers. So that's the power rule in action, a quick, reliable way to solve derivatives. We practiced examples, then double-checked everything using both the online calculator and the TI-84. The more you practice, the faster this process will feel, and soon it becomes second nature. Thanks for watching, and don't forget to like, share, and subscribe if this helped you out. See you back soon with another educational video. Thank you. Goodbye.